Hello ladies and gentlemen, this is Ron Doyle on Maryland's Eastern Shore. I'm a master electrician. I wanted to give you all a how-to video on how to mount a Arlington vinyl siding block and meter socket, 200 amp meter socket for underground feeder to a 2x4 or 2x6 stud framed construction house. And the reason for this, I see a lot of electricians, they're mounting these meter sockets directly to the vinyl siding, and they have to wait for the vinyl siding to get up, or they have to cut a block of wood and trim wrap, or put a raw piece of wood slightly smaller than the outside width and length of this meter socket. You have exposed wood that can rot in the future, and the meter socket can get loose on the wall over time. So I use the Arlington 16 by 17 and a half. It's an Arlington product. I buy these through N.E.C Supply in Salisbury. They've got a built-in nailer flange. I usually use the truss head screws, or what we would also call labbing screws, to secure this to the wall. But I like to prep my blocks with the meter socket before I go out. So let's get started. First thing I have to do, I've got to run a 2-inch TA through this, and there's a little cheat trick to running these terminal adapters. Just thread, glue fit on this side through the bottom of this meter socket. And what I actually do is I flip this over and I punch out the center knockout right there, got it removed. And what I do is I'll take this TA and I'll line it up onto the base so that we break out the right knockout, and I'll run a magic marker around it to make sure we've got the right one. You can see the marker described in there now. But what I'll do is take channel locks. And I know a lot of guys don't do this. I find that it saves on breaking too many knockouts out. You want the specific one. So I'll set my N.E.C. These are a Craftsman's version of N.E.C. onto the bottom here, and I'll find out right where that weld is that holds it together. I'll get right beside it, and ever so slightly I'll rock it, and then you'll hear it break loose. And it takes a little bit of coaching. You don't want to go too fast on this. You don't want to break out too many. All right, got that one. Go over to this side, and I'll take it and I'll rock this one, and you'll hear it break. A lot of guys beat these with a hammer, and honestly, I've done it with a hammer in the past, and I found that it makes more problem if you beat it with a hammer and you break them out. Then you have to use a reducing washer on both sides. After I get that break out, I wiggle it, and I take it out, and that is the exact hole that we need for this 2-inch TA adapter to go through. So you can put your lock nut on, and you can put your fiber bushing on. So what we're going to do is we're going to take the long measurement on this vinyl siding block, and we are going to put the meter socket on it. And we are going to center this up. And I'm going to pull a measurement. We got 1 7/16 on that side, and we've got 1 7/16 on this side. Top and bottom we've got 1 13/16 on the top, 1 13/16 on the bottom. So I'm trying to keep this symmetrical. So what you're going to have to do is measure from the top, from the edge of the block over. Let's see if I can give you a closer view of that. This measurement over from this edge to the meter socket, you want to make sure it's consistent. And 1 7/16 at the top and the bottom. And then I'm going to take my Sharpie on these pre-stamped out holes. I'm going to draw a little circle where my holes need to be, and also where the TA comes through this vinyl siding block. I'm going to draw a circle so that everything is pretty much pre-laid out for me. Now that I've got 4 holes marked, I'm going to take my meter socket and set her to the side. And what I've got is a starter bit, because what we're going to pre-assemble this with is 1/4 inch short, 1 inch, 1/4 by 1 lag bolts and 1 washer. So you need 4 of these. Get a 1/8 inch drill bit, and get those measurement marks pre-drill. Now this bit is smaller than a lag bolt, and there's a reason. It's because we want those lags to fit in somewhat tight. Now on a cross reference from this is a 3-inch. It's going to be a 3-inch hole saw. Now what you can do is a cheat trick. Pretty much any hole saw mandrel will work if you've got the vented holes in the back, but I'll usually spin this off. This is another cheat trick I learned. But if you take this, see your black mark, and you line that through, you'll be able to find the center of that hole just from lining that up, such as so. Doing a circle inside your mandrel hole, that will give you a bullseye target to drill through. And I'll take the mandrel with no hole saw, and I will, don't drill through your tailgate. We're doing a utility body job, but we don't want to do a utility body hole through it. So now that I've got that started, start your pilot point, run her off the side of your truck tailgate, drill through, and usually pop my slug out. Put my slug in the trash box because you're not going to need that. I'll get my blade out, and I'll scribe along this. You'll have a little whisker coming up from that hole saw. Throw that in the trash box. This side's not so critical. Basically, the benefit of doing all this and getting all this mounted on the wall is the vinyl siding guys are not stopping you from mounting a meter socket, and you're not stopping the vinyl siding guys by putting a block of wood that they have to J-channel around. This is a quicker way to get this on the wall. Now, these siding blocks, before pre-COVID, they were $17.50 to $18 a piece. They're now running around $23, $24, and they are scarce. It seems that Arlington is not able to catch up with production and the supply and demand that all of us are facing. So, we got 4 short lags. We're going to change our bit on a driver, and I have a 7/16 long nut driver, magnetic, and I'll pre-start my lag bolts, and we're going to put all 4 of those in. That's required, and this is a temporary means of mounting until you get all this level to the wall that it's going on, and after you get the meter block mounted to the house, these little short lags will be removed. So now that we've got that already screwed down, we're going to take our TA adapter. We're going to run our TA adapter through it. We're going to put our lock nut on it, snug it up, hand tight. We're going to put our fiber bushing on it. And just so this stuff doesn't get displaced before I get to the job, I'm going to go ahead and put our wireman's blankout cover on it. I'm going to put our Arlington bridge block inside of it. And this application on a 2x4 wall, I'll use a box adapter, a glue-in box adapter to the back of a TA adapter, and I'm finding out that these are just slightly shy of the length that you need to glue the TA adapter in. And what I've been doing, I don't have one here to show you now, but I'll take a 1.5 to 2 inch reducer bushing. I'll run a hole saw in there because it has a little chamfer on the inside. I'll drill that reducer bushing out, and it's basically in essence the same thing as this. It's slightly longer. It's about 3/8 of an inch longer than this box adapter. I'll use those when I have to mount this particular setup to a 2x4 wall. 2x6 wall, you're doing 2 male adapters. I always do single strand number 4 alt going to my 208 meter sockets. I'm not using SAE or SAE. SER, I'm sorry, or SEU. I'm pulling direct feeds through this, and I'm using duct seal to seal around either the inside or the outside of the application. So this is part 1 of prefabbing these up, and normally when I'm doing these, I'll do 4 or 5 of these at a time. That way they're sitting on my shelf ready to go for a job. But where we're in COVID circumstances right now, a little hard to get these meter sockets. I just had a buddy of mine show up at my house to buy a meter socket off of me. That's the only other one I got. Right now we're in COVID shortages, and that's what we got to do. Look, stay tuned for part 2 of mounting this on the wall and speeding up your production time. Stay tuned. 60, 40, 80 panels, and 200 amp meter sockets. Tips and tricks of the trade to speed up your production time, so you're not on the job site as long. Hopefully this helps give you a little walkthrough of what I'm doing. We've got a garage. It's the entrance of the garage coming into the house. That's egress for the house. All right, we're locating this panel in this second hole bay, that one right there. So we want to look up. We've got a ceiling joist to contend with, floor joist, because that's load bearing. So we'll have to straddle our wires on either side of that floor joist. But the reason that I choose to do closest to the interior wall instead of to the exterior wall like a lot of electricians do is there's a lot less boring, a lot less wire going through the wall. We're going to hide the meter on the back of this house. So first thing we want to look at is any potential nails coming through the sheathing. I've cut them off. And we want to make sure just above this area, we want to make sure we don't have any obstructions, load bearing supports, pipes, anything that's going to be in that way. None of the trades are here. I'm the first one. Concrete's been poured, house is framed. We've got Tyvek on the walls, and the roof is on. No windows, no doors. They're on order, and no vinyl siding yet. But what I'm going to do, I've got a template made out. This template is a big time saver. A lot of guys, electricians I know, do not use a template. Most people aren't aware, but when you buy a square D home line panel, this center knockout is not centered in the panel. Overall panel width is 14 1/4. It's 200 amp main. You got 7 1/8. 7 1/8. Okay, this is their center mark. This is where their center is of this TA, and this is the center mark of the panel. So you can obviously see that this knockout is not centered. So what I've done is made a template. I always face paint out to me so I can see it, but this is a mock-up of the hole centers, main breaker, and this is the lowest breaker. In case I have to invert this, I'll know where the highest position is. And this would be the highest position breaker. And this is where a 30-60 spot panel would stop. And this is a 40-80 spot panel would stop. And these holes are duplicates on the 30 also. So I can take this board without a panel and go to a job, and I can vinyl prep it with the meter socket, the light blocks, and other things, so that I'm not holding the vinyl siding guys up. The contractor calls me up. He says, hey, I need you to prep this house before the vinyl siding goes on. Right now we're in COVID shortages. We don't really have an issue with the siding guys jumping on me that I'm in their way and I'm slowing them down. But I made this template, so I can take this template in any house, get my marks. I've got my mark at 72, and this template will fit in this cavity. Now, if it fits in this cavity, I know it's good to go. So any of these cavities, let me see if I can find you a short cavity. and you'll get the gist. You see how that one down there is sticking just a little bit. But if you walk in a house and you have a tight cavity, you'll know if the panel will fit there or not. There's been cases where I've seen electricians put the meter socket on the wall. They'll come back and they'll throw that panel up in that wall, and that wall won't, it won't fit. You need 14 1/4, and they've got like 14. So what do? You cut the sheathing nails in between the sheathing and the stud, and you beat that sucker over. Well, there's a problem if there's a joint in between a seam in between your stud. Now you got OSB or plywood hanging in limbo, which is no good. A lot of these marks line up, which tells me there's no joints on this stud. That tells me these line up, these marks line up. That's no joints in that stud. Don't always use that as a guide. That's like a rough guesstimate. You really need to know if a panel's going to fit here before you get started. So I've got this board made up. Now, like I said, always facing me. So I'm installing this like this to do my hole layout, whichever hole I decide to use. And primarily, it's the one in the offset center at the bottom. So that would be the back of this panel. That template shows me a layout of every hole on a 40/80 panel. If you see that, it gives me the outside width, tells me where the main breaker is going to be, gives me the highest point, gives me the lowest point for the breaker. I didn't paint this side because I always know I'm looking at the painted surface. This is what I'm working with. So what I'm going to do is I'm going to slap this up on the wall. I'm going to drill my template, and I'm going to show you how this speeds up production. Stay tuned. All right, we'll take our template, put it in a hole, we'll flush it up to this side. We're going to put it on 72 inches. That's where I want the top of the panel to be. We're going to take our 3-inch hole saw and place it in this template guide. It would help put it drill move from the following day. Right, we got it speed 2. Shout out to the N.E.C mandrels, quick release. I love this thing. Put the hole saw on, start it on slow, line up your holes, push it forward, done. Very nice product. I would recommend that to anybody. And what we're going to do, we're going to get a meter socket on first, then we'll come back in here and I'll show you how to install the panel with 2 TAs and a short 2-inch PVC nip. Alright, we got our meter socket all prepped. We got the knockout popped out of it. We've got a TA installed, lock nut, fiber bushing. This is my little cheater for my lineup. We're going to insert this into the back of it. That's such a so. We're going to insert this into the wall. We're going to take our 12-inch magnetic torpedo level, and what I'm going to do is take my marker, and we're going to find level and center in that hole that's in the wall for an easier lineup. So, got my torpedo showing level. I'm going to draw a line going across this way. And that's on the bottom center. I'm going to draw a measurement with it all the way to the top, level out again on my top mark. Take my box. I'm going to slide it around until I can find far right. We'll draw a little mark. I'm going to slide it to far left. And draw another mark. Oh wow, look at that. We got a tic-tac-toe board right here in the corner. So what we're going to do, I've got a 3/4 inch short head truss screws. We're going to secure the block. After we get it secure, we're going to come back and we're going to secure the left side first, and then we're going to secure the right side. There's a stud in this corner that'll line up, and we'll catch long lags on this side. We'll use T-nuts on this side for quicker installation. So I'm going to center this up in my tic-tac-toe board. We're going to get a screw started on our drill. I use screws instead of nails. They're easier to remove and reposition. I'm going to get her lined up, get her level. One screw in the top corner of that flange. I'm going to make sure she stays level. I'm going to check, and I'm going to put a screw on this side. Okay, she looks good. In the center of the tic-tac-toe board, and we're level. And we've got one screw holding each side. I'm going to go round back inside the garage, and we'll make sure that it is truly lined up. Stay tuned. We got a little wiggle room to play with. She's a little bit offset in the center of the hole in the garage, but she's good enough to line up our 2 TAs. So we got this level. I'm going to confirm that this is level. I usually confirm it on the right and left side. Sometimes these blocks are slightly out. You might have a little sharp edge on one side and not on another. Or these blocks that you get from Arlington are actually slightly bowed and they're distorted. We're slightly out on that. Now on the box top are level. She needs to go that way a little bit on this side. So we're going to do an adjustment. Nice thing about screws, you can loosen them up. You can tweak them a little bit, make them right. Nails, a little bit harder situation. Perfect. So what we're going to do, we're going to install all the screws around this. Now for water flashing principles, I want to do a reference mark on both corners at the top. Alright, and I want to go where this built-in J channel is. I'm going to go up about 3/8 of an inch. I'm going to put C for cut. My marker's running out on me. I'll do 3/8 on that side. And that's up from the bottom of that J channel flange that's built in on the siding block. So what I'm going to do is preset me a couple screws and we'll back them back out. we'll have a reference point. I'm going to take those screws out, those 4 screws. I'm going to cut these corners here and here so that we can get that paper, that tie back, pulled back. Marking my inside corners. And this is the top. This is what we don't want to cut. What we're going to do is take this off, we're going to make a fold. So I'm going to take my torpedo level, I'm going to run a line across here. Connecting them together. And then I'm going to take my 45 on this, run it off that corner. My marker's running out. Run this 45 off this corner. Alright. It's hard to read because my marker's running out, but I'm going to take a utility knife. This is the top corner. We're going to cut down on that 45. We're going to cut down on our 45 on this side. Alright, this is our line we're going to cut. Alright. This is our fold flap. And we've got our nice trusty loose tie-back tape. There's a cheat trick to cutting this stuff so it don't get all bumpy on you. Take, instead of cutting across, put a hole in the middle, pull. Saves a little bit of aggravation. And you don't want it to lay back on itself, so you end up going, stick it to the wall a little bit. We're going to set this back up in here, find our screw holes, and reinstall the screw. I apologize for the wind, I wasn't planning on that today. You can't always plan for a perfect video. You can hope for it, but you can't plan for it. Alright, now I'm going to do a quick check, just make sure we didn't get any of this out of kilter. Alright, she's still looking good. She got out on that. Let's get the block secured. And then we'll tap this meter socket. I see my holes are still lined up. So we got 2 slots for each flange. I'm going to go around and secure them all. And what I'm using is a 3/4 inch truss head screw. It's got a wide screw, not like drywall, it's flush. So it pulls that even pressure against that wall. It's nice tight. And you don't want to go too far into the structure because of your panel. Now, 2x4 wall, that panel's going to be slammed up to that back of that 2x4 wall right at the sheathing. And that's the perfect installation for using T-nuts to mount this meter socket. Now, for illustration purposes, I'm going to be using T-nuts on this so you can see how they work. I started using T-nuts probably 10 years ago due to the problems where there's not enough depth in the wall on a 2x4 wall. And the electrical inspector seen that, and he started asking me, where did I find out about all that? Well, T-nuts have been around a while. Very few people know about them, and this video is to inform you all. They have multiple purposes. Mostly used for putting a board to a steel frame, and then having it material wrapped in foam. So when you run a bolt up underneath that steel frame and pull that plywood down to that frame, you won't feel that nut or that bolt protruding through. It'll be nice and flush. No sharp edges going through the material. So now that we got all the flanges secured, I'm gonna do 2 more on the top. All right, I'll start my taping at the bottom. We're gonna pass the flange area by about 3 or 4 inches. Now I'm going to do my sides. Now we're going to do our top. Now, look down inside of this, we'll have about 3/8 of an inch of void so that I can get this tape attached to the inside of the siding block in this tie back here. And I'm going to keep this moving until I find bottom so it don't stick. Once I get this insulation done, ladies and gentlemen, I'm going to come back. I'm going to put caulk on 3 sides. And I'm going to leave the bottom open, so if any condensation builds up between the metal and the plastic, condensation will run out the bottom. The idea is to keep water from rolling down in here. We are under a roof line. We'll keep water from rolling down in here on top of the TA and then wicking back behind this material, behind this block and this tie back. Trying to do water intrusion prevention. We don't want any water in the wall. So now that I got this somewhat secured, I'm going to check it again. Now the bottom siding block is going to move. It's screw tight. So I'm going to do a minor adjustment. there. Good there. Top is a little bit out of whack. So this top is rolling downhill there. This is level here. And this side is perfectly level. So there is some inconsistencies inside of the construction of the meter socket. So what we're going to do, now that we've got it level, we're going to take this off. This is going to hit the ground. We're going to take this short lag out that I pre-installed. You'll see that in the first part of this video. Alright, there's a stud right here. You're going to drill slightly on an angle, ever so slightly. And we're using a 3/16 long drill bit. That's 12 inches long by 3/16 diameter. And the drill is on the inside. Stay tuned. Alright, we got the drill. We got the 3/16 long shank drill bit chucked in here. Put it on a slight angle, level. Put it on a slight angle going in. Alright, I'm going to go and check inside results to make sure we're okay on that. We are perfect on that. I just confirmed it. We are using 1/4 inch by 3.5 inch lags. You can do different lengths depending on your application, but going from the meter socket, getting the spacing, because this is a hollow block, and getting into your plywood and your stud, so you have a solid installation. You don't want to use anything less than 3 inch. This is a 3.5. And the main reason that I'm using these 1/4 inch fixtures, they all have 7/16 head, and pretty much everything that I'm doing, I'm using one bit. You're not changing bit to bit to bit. So your temporaries, where 1/4 inch by 1 inch lags, I've taken them out and removed them. You can use those for the next installation. Now we're inserting these with the washer. You want to pay attention to this back side and how much you're compressing this meter socket into this block. I'll usually end up with a gap about 1/8 of an inch on this back side. So confirming we're still level. Okay, we're going to take this 3/16 bit out. Now we're installing a 5/16 by 12. The reason why is you're trying to get past the cabinet and through the wall. And if you use a short drill bit, you're going to find that you're cattywampus in your hole, and going through, you're going to get hung up on your drill because your holes are in this corner. So I'm going to chuck this in the drill, tighten it up. We're going to take and remove our temporaries that we installed. We're going to take this drill bit, drill through. Now you want to make sure you're straight, you're level, and go straight through. And the reason why is you want your alignment on your T-nut to line up with your bolt, so you're not cross-threading it. Now we're going to go on the inside. I'm going to show you how to install the T-nuts to speed up this installation. Alright, we're now on the inside, and we're going to be installing these 1/4 inch by almost a 1/2 inch. I think these were 1/4 by 7/16 when I bought them. These are going to be pounded into the OSB. So we're going to take our hammer, we're going to rake off the chips, we're going to insert this. Alright, beat that one in. Same thing with this one. Take your hammer, rake off the chips, because OSB needs a jagged edge. We want to make sure the chips are out of that hole. Insert this one. Now for a 1/4 inch fanged T-nut, you want to make sure you use a 5/16 drill bit. That's for the barrel to go through the plywood. Now what we're going to do is we're going to secure these T-nuts so they can't fall out. So what I'm going to do is insert a 1/2 inch lapping screw, a little shorter than what we used for the mounting of the vinyl siding block. We're going to put one on either side of this T-nut. And this won't affect the vinyl siding at all. It doesn't go past the OSB. And this is just to fence that T-nut in so it won't come out. So now we're going to go back on the outside, and we're going to finish installing a meter socket. Now on this side, where we drilled our holes through for our T-nuts, I marked T-nuts on the inside of the meter socket, top and bottom. This side I marked lags, so that if somebody comes back in the future and has to change this out, they can swap this out with the same principles that I'm using right now. They'll be able to use lags on this side, and they'll be able to use the T-nuts that are already installed in this wall. They won't have to cut the wall open, they won't have to put blocking in the wall to secure this back to the wall. And what I'm doing is right now I've got a 1/4 inch by 2 inch, a 1/4 inch by 2 inch grade 5 bolt. You don't really need the strength, you could actually use a grade 2 out here, but it's a 2 inch bolt. They don't make a bolt size from my distributor, I buy these from Tractor Supply. They don't make a bolt size that is 1 5/8 inch. So what I've got made up here, you see the 1 5/8 inch that I need. Basically, this is a 1/4 inch washer, flat washer, and this is a 5/16 nut is used as for a spacer. So I insert the nut on there first, insert that. I'll take my nut driver, so it's long shank, 7/16 head nut driver, and it is made by ABN, which is auto body. I'm online. They're not that expensive. You can buy a whole set. Well, we're going to pre-start these to make sure that we don't cross thread that T-nut in the wall. All right, got that one started. And we're going to take our one for the top. We're going to start one on the top. I had a little bit of problem with that one. I'm going to get another tool that's going to help this installation. This, ladies and gentlemen, is a Klein Tools screwdriver shank extension, and it varies in length. So pull that out to insert this. If you want to remove the bit, pull it in and pull it out. And what I found was 1/4 inch shank, you can use these nut drivers on it. And you can feel if you're cross threading or not. And it's going in with no problem. So I'm going to pop this back into our impact. We're going to pay attention to our gap, the reveal going around this meter socket so that it's consistent. Alright, we got a consistent tightness on all four. The reveal is all the same all the way around. Now the biggest thing about emphasizing the strength of this box onto this wall structure, I've went up to do trenching that other electricians have done, putting these on the wall, and what they're doing is they're using short lags. They may be using this final siding block, they're using short lags, and they're only relying on the wood on the sheathing on a 2x4 wall. They can't use a long lag bolt because a long lag bolt will impede the installation of the panel that's on the inside. Now you'll be able to catch these with long lags like I did, but on this side you won't be able to use long lags, they'll have to be short ones. And what'll happen is, I'm doing the trenching, and our requirements in this area now through Delmarva Power, Chop Tank's not doing it yet, but Delmarva Power is, you have to do a 3-inch conduit. 3-inch conduit is very, very stiff. The person that does the install, that does the trenching, he has to do a long sweep 90 coming up from the ground, and he has to do a transition from long sweep 90 up into the bottom of this meter socket. Well, you're getting a long stick of conduit in the ground with sweep 90s, you're going to be torquing really hard on this side. It is quite possible that you'll rip this meter socket off the wall if this is not secured just by putting the conduit in. Now, I've been to other houses where this meter socket wasn't installed properly, and this sucker's hanging off the wall, and the conductors that are going through are actually being cut and chafed from the sheet metal and the TA where it's separated, where it got so loose it broke, and it is now chafing on the inside. Water is now getting down in the wall and leaking. It makes problems for everybody later. Why not do it right? Let's do it right. This speeds up installation. This didn't take that long. I showed I use George Landing, Maryland Electrical Inspections. He's seen me doing this about probably 8 years ago, and he said, I like it. He said, how was that held? How are these bolts held in? How did you get a nut back there? There's no room. And then I brought out a T-nut. He said, wow, I've never seen that before. I said, well, this is the best thing since sliced bread for electricians. Electricians don't know about this. I'm emphasizing use T-nuts on this side. It saves a lot of people a lot of trouble down the road. Those T-nuts are about 50 to 60 cents a piece. Well worth the expense. Well worth doing. It's better than a lag, especially on this side. Now I'm going to take you inside, and I'm going to show you what the inside result looks like. All right, now we're on the inside. And if this be a 2x4 wall, which this is not, this is 2x6 wall. If this was a 2x4 wall, the thickness of this panel will take up the whole cavity and still stick out. It will still stick out the ½ inch that it needs for the sheetrock. So you would have a ½ inch of this cabinet sticking out for your finishing of your sheetrock. This installation, this wall is deep enough, but I'm using this as an illustration. There is no protrusion on this installation. This bolt, this little bit that's right here for the thickness of the screw head, and the thickness of the screw head will not impede the installation of this panel in a 2x4 wall. If you're worried about that impeding the installation, I'll just give you a little illustration of this. These are bump outs. These are for hanging the fixture on the plywood. I'll zip a screw on the right and the left side, and these actually stick out 1/4 inch. That is not going to stop anybody. This is a better installation. It is much quicker to pre-assemble your meter sockets and have them prepped and ready before you go to a job site, in combination with a template. This template is kind of a foolproof, letting you know that a panel will fit in this space. So stay tuned. We're going to get this electrical panel installed into this wall cavity. Bear with me. I know it's windy in here. Now on these panels, one thing that I want to make everyone aware of. I don't know what's happened if their dies that are stamping these out into Square D factory are getting dull, but you have to be very careful with these flanges going around this cabinet. I've had these flanges on some cabinets be real sharp, and if you slide your hand down the cabinet, it'll slice you open. On this particular panel, this top rail and bottom rail was sharp enough. I slid my hand across it and it cut me. Be careful. You can take a 120 paddle wheel and a 4.5 inch driver, and you can knock that edge off so that you're installing this. You're going to be safer doing so. I hope Square D finds this video and monitors this. I get a lot of cuts, mostly from wire, sometimes from panels, sometimes from meter sockets, so be careful. So, I got my bit changed in my M12, and what we're going to do is we're going to tack up the bolt to hold it and position this so we can get a measurement. So I'm eyeing these two TAs, I'm eyeing it together. Okay, that looks lined up. Alright, we're lined up on our mark. Push the panel in. Now I'm securing tight to one side, this side. I'm going to shim this side out. We're using number 12's hex head lags. They seem to be sufficient. The electrical inspector that I use does not want to see drywall screws or deck screws. He wants something a little bit more sufficient. The reveal you're looking for on a wall in the garage, if it is adjacent to living quarters, this wall will be 5/8. This wall is adjacent to exterior, but this wall from here over is adjacent to living quarters. They're going to sheathe this whole wall out with 5/8. So I know I need between ½ inch and 5/8 on this reveal, on top, bottom, on both sides. So the other thing this, instead of using the tape measure, the other thing this is great for, if you put this up here, you can use that to flush off to see what your distance is. That template has multiple uses. seen me, I had that in the reverse direction. I was trying to burn a little hole as a starter point so that my screw wouldn't walk into the old hole. That's another cheat trick. Now see, I'm using this as a shim. That's flush. Now I'm going to snug these up. Make sure it didn't move. Okay. Now, I'm not going to get too crazy with this because we've got to shim this and secure it, but we need the measurement for our pipe nipple that goes from TA to TA. So what we're going to do, I'm going to hold this back to the wall so it feels like a 1/2 inch. I'm going to run my tape measure in here for inside shoulder to inside shoulder of each TA and get a measurement. And we are looking at, I'm going to allow for 1/16 of clearance, we're looking at 3 5/8. 3 5/8. I'm going to cut that right back with you. All right, I got my measurement laid out. What we're doing is shoulder to shoulder on this here. So shoulder to shoulder, we're looking for 3 5/8. This is how I do my layout. I squeeze it, hook the tape on the shoulder, find 3 5/8 on the other shoulder of the other TA. In fact, a marker. We're going to mark the inside of that shoulder. That shoulder is approximately 1/8 inch thick. So inside, so our measurement's 1/8 inch less. We'll take a circular saw with a curved out blade. We're going to leave the line. Let's just check, see what that looks like. I'm going to take a paddle wheel. I'm going to touch this up, bring that burr off. So we got a 120 grit flapper wheel. Grab that up. Grab the tamper on that. Make sure our inside's not sharp, which it's not. And a 120 wheel is great for this. Let's do a dry fit. Got it pushed together. And look at that. We're at 3 5/8, just what I need. So I'm going to go ahead and glue this up. We'll go ahead and get this installed. Alright, we'll pull the panel off the wall. Got the TA glued together. I'll take the TA. We're going to insert it like that. We're going to take our panel. We're going to get a latch screw. We already got our positioning, so we know we're going to land. We know what screws we're using. We know what holes we're using. Get that one started. Alright, we'll make sure that we still flush. So, flush here. So I got my assortment of shims that I keep with me. The problem we stack, we got about a 5/16 gap in there. See if we can get away with one shim. And we'll have to break the shim off to get our depth. Get the skinny part, gets the thick part. Such as so. Alright, I'm going to take another one for the top. Put our thick part in. It looks like our thick part is good enough on top. To get our thick part set in place. And I'm going to use a pre-drill bit so we can get this lined up. I'm going to use this for my shim. Just have to get it lined up and flush. Pre-drill. So quick release chucks save a lot of time. Snug that up. Go back, get it ready for the top. Flush this up. Our bottom's still flush. We're going to pre-drill. Alright. We're going to take and put our last bag screw in. Okay. That's snugged up. We're going to take our utility knife. Store these off the back. So that our sheetrock not stick. Alright, so our sheetrock won't have anything coming out on it to stop it from being laid back. So now we're going to get our lock nut and our fiber bushings installed. This part sometimes is better done with 2 people. Now I've got my small channel lock. I don't even have a number on it now. These are very handy for doing light work application, especially with PVC up to 2.5 inch. You don't need a whole lot of torque on. This is a very useful tool. It's under $20, and they make these in I think 3 different sizes. This is the smallest one, but you can get it adjusted. Get right onto that nut, snug that nut up. Like I said, it would be nice if somebody was outside. What I might have to do is go back and forth and put both lock nuts on and keep working this until I get it cinched up nice and snug. Stay tuned. All right, got that both of those TAs and that pipe nipple installed. The lock nuts are tight and the fiber bushings are installed. Now we're going to insert the ground wire. trying to coach this ground wire in a fashion that I'm staying away from these knockouts. I'm going up on a 45-degree angle in case anybody in the future would ever need to pop these out. They can without this ground wire being in the way. Try to pay attention to detail, make it easy for the next person that has to get something in this panel is definitely a help. Somewhere halfway is copper, somewhere halfway let this over, and install this ground wire. 6 inches drop, that's not too bad. Done. Let's go ahead and start putting the feeds in from the inner socket to the panel. We're getting ready to prep our feeders. I've got 5 bands of red tape already installed on this aluminum feeder. Insert this into the wall. I'm going to do the facing the meter socket. I'm going to do the right side first. That's the one that gives me the most difficulty. Then the neutral, and then the facing the left side. So we're going to insert this. We'll go on the other side of the wall. We're going to hook this up. All right. We've got our N.E.C dia.x wire lube. It's basically to keep a wire oxidation from taking place. Looks like writing on cameras backwards. Sorry, ladies and gentlemen. Insert that in my holder. What we're going to do is we're going to take these lugs loose. And this is a 5/16 on this particular meter socket. It is a 200 amp Semens brand. This is for underground feeder. So we're going to remove the right side and the left side, and we're going to remove the neutral lobe. And we'll get this hooked up on this right side, which is the hardest spot to hook up in this panel because of it being close to the sheet metal. Take our wire, we're going to skin back 1.25 inches. Right, so I'm running the mark around that. This is just a straight blade utility knife. Alright, and I've got red marking for one side. It don't matter which side. I always do the boater's motto, red, right, return. So we're going to bend this up. We're going to take our Racketeer's bend awl. Fits on a 1/2 inch drive ratchet. I got a 1/2 inch to 3/8 adapter, so I don't have to have a big ratchet to do this. Get a little bend in that direction. Put a bend in it this direction. Take a little bit out. We're going to check for fit. A little bit more at the top. Check our fit. Now, one thing the inspector doesn't want to see is he doesn't want to see no more than a quarter inch past the top of the lugs. So we'll have to do a little bit of trimming. And I'm going to go get another tool that I like to use for trim. Went and got my N.E.C linemen's. These are 9/12/240T. They've got the lanyard arrest if you decide to use that on the inside. The reason I love these things is they've got such a big opening. You can trim 4/0 wire and cut 4/0 wire right through this. This sucker's awesome. So what I need to do, where I have to put a little twist in it, I need to trim off the tops, like so. Now that I've got it so it's nice and fitted, take my dia.x, lube that wire up. I'm going to put our clamp on there and snug this up. Now, if you notice, all my tools are readily available. One thing that I've learned over time, you want less bending, you want less maneuvering back and forth to either workbench, the ground. You want all your tools right here. So I utilize the tough pouch system. They can be clipped on my holster on my side. They can be stuck to the meter sockets. And all right, ladies and gentlemen, I've got the red right hooked up, and we're getting ready to do the neutral. Now this neutral is a 4/0. That's what I've got with me. It's a little oversized for a neutral. You can actually get away with 2/0 in the neutral, but the black jacketed wire that you use have to be re-identified with white tape. So now we're going to coach a half circle, and then I'm going to bend this back to a straight position, and then I'm going to coach the half circle again until we get this configured where we need to go. And 4/0 is pretty stiff. You really need some coaching tools. And I highly recommend the Racketeer's fender. Got a patent number. I don't see a model number on it, but look it up under Racketeers.com. And this is all aluminum, and I've been using this for probably 8 years now, and it's been great. Highly recommend it. All right, get this situated. Stop. This stuff is stiff. Right, now that I got it in position, I'm going to score a line. I want it a little better than that. Quite today. All right, that's better. We're going to take our razor blade. We're going to put it in there. We're going to mark just below the lug. like so. That's going to give us a reference point. We're going to score around it, like so. Cut it off. Be careful not to cut your fingers. All right, check it for fit. Yep.
Work too hard today.
I'm gonna try not to.
You know what I mean?
Yeah, I'm gonna try not to. This wind, if it dies down, we'll be a lot better off.
Will it get worse, I think, today?
I don't know. I didn't listen to the weather.
Yeah, I think it will get worse.
Yeah, I wouldn't be surprised though.
I'm sure.
I would not be surprised. As long as it's not raining or snowing, I'm good. Have a good one now. All right, we got that in position. We're gonna leave that up with some antioxidant. We're gonna get our clamp. Well, we'll put a little bit on the back of that clamp. We're gonna get our clamp in position. Try not to get this crap on my fingers. Before we get these connections done out here on the side, we'll do the connections inside. You want to make sure that none of the insulation is caught up into that clamp. You want to make sure you got a raw conductor under that. The inspector looks for that. He will check it. He will fail you if you have insulator in between the clamp. Don't want to over tighten these. And it's recommended you use a torque wrench with torque specs that are inside on this label. I've been doing this a while. I can usually judge it. Alright, we'll go back inside. I'm going to trim the neutral to length. Come back outside and we'll hook up the last one. Okay, ladies and gentlemen, I got that one cut. It's on the inside. We brought this extra wire back out. We're going to do this last leg on the left side it's facing. We're going to coach a 90. And then we're going to coach an offset. And check it for fitness. Alright, it looks good. Score a little line. Getting that back. Now this wire doesn't have to be re-identified. This one is as it is black. Dip it in a little antioxidant. And if y'all wonder, this antioxidant is being held on by a little product that I made. It's got dual magnets. It can be stuck to either side. You always need a rag dealing with this antioxidant. And when I get low, I've got a acid brush that goes into the holder on the sides. When I get low, I can dip into the bottom of the bottle. This is just a piece of vacuum hose, a little easier to hold on to than that small brush, but pretty much this can be stuck anywhere on this meter socket and clean my hands. I've got something to clean my hands with. Magnets, very useful around the electrical trade. 5/16. We're going to snug this last one up here, and then we'll go inside, do the connections in there, and then we'll come back outside and we'll put the duct seal around this connection. You don't want the outside temperature to reach the inside temperature and condensate. We'll try to prevent that. Alright, we're now back on the inside of the garage. Got my kneeling pads to help out a little bit. We want to take our 3/8. These are Klein's long extended 3/8 T-handle Allens. We're going to loosen each one of these up just before they get to the position where they want to fall out. This one's tight. Usually they're loose. Alright, we're going to start with this red one here. Got it pre-marked. That's what needs to come off. We'll take our antioxidant. That up. Take our racketeers fender. Snug this one up. Now, I told you all about taking the burr off this cabinet. This is a good example of when you're going to get sliced open. Not taking that burr off, you're going to slide your hand around this. Got that one snugged up. We'll put your protector cap on there. That one's done. I'm going to take our fender. I'm going to coach this one with a bend in it. Now, you can hold it up there, take your utility knife, score a line, so you know how much to strip. Take our antioxidant again, we'll leave this one up. Don't put a whole lot on there. making sure that you do not pinch the insulation. We'll make sure you got bare conductors going up that clamp. Lug, clamp lug. Alright, let's do this last one. Over up in position. Get your knife. I score a line for the cut, and I score a line for the skin. Alright, I got my Greenway 760s ratchet cutters. Cut that. That's our drop, 6 inches. Not bad. Score around this. Peel that jacket off. Get your bender again. Put it against your lug. Coach that. Now if you have to trim her up a little bit because she's not quite square, get your nip-backs and square it up. I'll dip this wire too. Very important to get some antioxidant on every one of these wires. Keeps the corrosion down. All right, I'm gonna snug this one up. You want to make sure that none of these conductors are fastened to cabinet face. Now, if you get this one snug, if you need to tweak it in a little bit, you can put this bender on here. Get a little bit more leverage. Tweak it down a little bit. Now, leaving this void in the back of these conductors. Your conductors are coming down or coming up. If you have to choose sides, you can actually use this path to run your conductors going up the side of the panel versus going right across the bottom. It helps on your install. Gives you a little bit more versatility. I'm trying to support this conductor as I'm snugging the lug up. Now we're going to put a cap on. That takes care of the inside. We're going to get our duct seal, and we're going to put some duct seal on this now. Alright, I got our duct seal out. This is a Bridgeport brand duct seal. This is a 1 pound bar, and I've got a leftover from another job. But it doesn't take much. You only have to do one side of the panel, either inside or outside. Most of the time I do it inside because that's where the inspector shows up first to look at this. Sometimes they'll open the meter socket and look inside there. Sometimes they don't. They have authorization to do that. I don't. So we're going to roll this between our hands, get it pliable, and then we're going to wrap it around this over top of the fiber bushing, and we're going to meet it in with our fingers and try to seal off every void. And it looks like I need a little bit, just a little bit more. So we'll do a guesstimation here, and we'll pinch some off. Don't need much. I already got something to work with, but all right. Meet that in with your fingers, and we'll get this wrapped up here. Just make sure you got enough bands of tape showing what the conductors are. If you're covering the tape up, you want to cover the last piece of white up that you got, you want to make sure you put another band of tape so that they can see that it was re-identified. All right, ladies and gentlemen, we are done with our panel install. Got this duct seal around here. Got our conductors, they're in tight. Our protector caps are on, and ground wires hooked up. Next thing is putting our nailer blocks for wire poles that go under the house. Got to have a nailer block there, and we've got to have a nailer block within 12 inches of the top of the panel. I'll usually put one in the middle, and I'll put one within 12 inches of the top of that panel across. Let's walk outside. There we have our meter socket. We've got all the connectors coming through. The connectors coming through. Got red on the right, white. You can see white's re-identified, and you got the left conductor. Delmarva Power or top tank will come out through this knockout on the left side of the meter socket and come up. These are their connections. This is a neutral connection. These are the two highs. Look, this is Ron Doyle with you. This video is to give you some insight on how to wire up a 200 amp meter socket and electrical panel. I hope this video was helpful and informative to you all. If you're planning on doing any of this work yourself as a homeowner, check with your local authorities and see if they have provisions for that, and you can do it yourself. If you like this video, please give me a big thumbs up, subscribe, help my channel grow. I'll look forward to doing more of these videos in the future. God bless you all. Have a wonderful day.